Okay, our third conic section is called the hyperbola. Hyperbola, or hyperbola as some people pronounce it, again, we're going to have the center at the origin. So, let's just jump right in. Here's the definition. So hyperbola is the set of all points in a plane such that the difference of the two distances from the two fixed points is a constant. With an ellipse, it was the sum. In a hyperbola, it's the difference. That's going to come into play here very shortly when we look at the equations. They have, if you look at your blue sheet, it shows you the shape of what a hyperbola looks like. A hyperbola will be something like this. It'll be like a curve out here and a curve out here. We would call that one horizontal because its branches are horizontal, or it would be up here like this and down here like this. We would call that one vertical because that would be, the branches are vertical. Okay, so here's definitions. Now remember, these did not change. Remember, A is still the distance from the center to the vertices. B is the distance from the center to the co-vertices. And C is the distance from the center to the foci. Here's where it gets a little different. Notice this guy right here looks an awful lot like our friend Pythagoras. And if we remember from Pythagoras, when a squared plus b squared is equal to c squared, that meant which one is the bigger number. It's no longer a, it's now c. C is now the bigger number for hyperbolas. Okay, let's take a look at the equations. Remember, distances didn't change. A, B, and C. A is to the center to the vertices, B to the co-vertices, and C to the foci. So let's take a look at our equations. So if we have a horizontal hyperbola, again, it would look something like this, and we're going to draw some extra things in here in a minute. Okay, or if we have a vertical hyperbola, it will look like this. Okay, it has two branches, a top branch and a bottom branch, or a left and a right branch. There are some differences between this and our equation of the ellipse. Okay, we start by doing this. Ooh, wait a minute, that's a minus sign. In an ellipse, it was a plus sign. Okay, so we go back to the definition. In an ellipse, we said it was the sum of the distances. In a hyperbola, it's the difference of the distances. That's why the sign changed. Okay, this otherwise looks just like the ellipse. Remember, the ellipse was x squared over a squared plus y squared over b squared equals 1. This was an ellipse. This is the hyperbola. Over here, we had x squared over b squared plus y squared over a squared equals 1. Okay, and in this case, the x's and the y's traded places, not the a's and the b's. In an ellipse, a and b switch. In a hyperbola, x and y switch. Okay, that's the difference between the two equations. So in an ellipse, a and b switch places. In a hyperbola, the x and the y switch places. Okay, otherwise it pretty much is the same thing. So let's take a look at what a hyperbola will look like if we graph it. Okay, just for grins and giggles, I'll leave that right there for a second so we can see those equations. Okay, taking a look, I have x first. So it must be horizontal. This one is, that's how I know. If x is first, if y is first, it's vertical. Okay, if x is first, it's horizontal. If y is first, it's vertical. So this is going to be a horizontal hyperbola. Now this one gets a little tricky, so let's take a look at how we're going to graph this. First of all, we need to identify our A, our B, and our C, and I'm going to bring out a couple extra colors here. All right, so first of all, we know we're going to start counting at 0, 0. That's a given because of today's lesson. We also know that A squared is 16, so A must be 4. We know B squared is 4, so B must be 2. Whatever letter they are under is the direction they go. So this is under X, so this is going to go side to side. This is Y, so it's going to go up and down. So I'm going to draw those on here, but I'm not going to use my green pen. I'm going to use this red one. All right, so I'm going to start at 0, 0. I'm going to go 1, 2, 3, 4 to the left, 1, 2, 3, 4 to the right. I'm going to go up 2, and I'm going to go down 2. And then I'm going to make a box out of those right there, just like this. Just like this. Notice they're the midpoints of my box. Okay, so far so good. And then I'm going to take my handy dandy ruler. I'm going to lay it across here so that it goes through that corner and that corner. And I'm going to draw a dotted line like this. I'm going to do the same thing in the other corner, just like this. What I am drawing, okay, remember we talked about these just the other day. They're called asymptotes, A-S-Y-M-P-T-O-T-E-S. And we defined them the other day by saying they are like curbs on the street. They tell us where we can and cannot go, and we can't cross them. So I'm going to go back to my green pen because I'm going to draw my hyperbola now. Oops, I forgot something. I forgot C. Remember, A squared plus B squared is C squared. So A squared was 16 and B squared is 4. So C squared is 20. So C is the square root of 20. Can you estimate that a little bit? Well, let's see. It's more than 16, so it's a little more than 4. The next one I come to is 25. It's not 5. It's closer to the 16, so we're going to call it about 4.5. It's pretty close. Okay, and remember, A and C always go the same direction. A went side to side. A was 4, so we're going to do an X right there at 4.5. We're going to do an X over here at 4.5. And now I'm ready to draw my parabola, or my hyperbola, sorry. Okay, here goes. I'm going to start here, and I'm going to go over towards the asymptote, and I'm going to follow it. I'm going to go from here. I'm going to follow the asymptote out to this direction. I'm going to do the same thing over here. I start there, and I draw it out like this. And I start here and I draw it out like this. That is what my hyperbola looks like. Now I know the box is kind of a neat little thing. It helps get me in the right spot. I need the box and the asymptotes. I need the box so I can draw the asymptotes. I need the asymptotes so I can stay in bounds. And that's what a hyperbola looks like. Let's try that again. Okay. All right, what do we know? Well, we know that we're going to start counting at 0, 0. We know that. Okay, I'm looking at it and I see that Y comes first, which tells me it's going to be a vertical one. It's going to go like this. Okay, I know that. A is still in the front, so A is the square root. A squared is 9, so A is 3. And B squared is 25, so B is 5. So I go the direction they are, under. So the 9 is under the Y, so this one goes up and down. And the 25 is under the X, so this one goes side to side. I know that's not what we're used to, but that's what we're going to do. So starting at 0, 0, let me switch colors again. I'm going to go up 3, 1, 2, 3. I'm going to go down 3, 1, 2, 3. I'm going to go left, 1, 2, 3, 4, 5. I don't know my left from my right, but it's okay. 1, 2, 3, 4, 5. And I'm going to draw that box, which looks like this. I'm not drawing it perfectly, but you can see what I'm doing. All right, then I'm going to grab my ruler. I'm going to go corner to corner, and I'm going to draw my asymptotes. I draw them kind of dotted. I'm going to go corner to corner, and I'm going to draw my asymptotes. Okay, there are my asymptotes. I need to find my C. Well, I'm going to take 9, and I'm going to add 25. That's what C squared is equal to, so that's 34, which is really close to 6 because 36 would be 6. So I went, let's see, A went up and down, so C is going to go up and down, so I'm going to go almost to 6. I went 1, 2, 3, 4, 5. Here's almost to 6. Here's 3, 4, 5, almost to 6. And I'm going to draw around them like so. I'm going to draw just like that. And there is what my hyperbola looks like. This one is a vertical one. Not a problem. Okay. Okay, what do we have next? Let's see. Okay, here's what we have next. We have a hyperbola equation, but it's not equal to 1, and all of our hyperbola equations were equal to 1 in the first place. So the first step we're going to take is we're going to divide everything. What do I have to divide 36 by to get 1? Well, I have to divide by 36. Whatever I do to the left, I have to do to the right, so I'm going to divide everything by 36. And look, I have fractions. So that gives me a new equation of x squared. What's 9 into 36? It goes 4 times. 4 goes into 36 9 times, and 36 goes into 36 1 time. Now I have the standard equation of an ellipse. I know it's horizontal because x comes first. X is first, so it's horizontal. AL, sorry, which means I'm going to draw like this. I'm going to have it look like that. All right, I know that a squared is 4, so a is 2. I know b squared is 9, so b is 3. If I add them together, 4 plus 9 is 13, so c squared is 13, so c is the square root of 13, which is a little bit less than 4, so let's estimate it at like 3.7. Sounds good to me. Here we go. All right, again, whatever letter it's under, that's the direction it goes. So I'm going to go 2 to the right. I'm going to go 2 to the left. I'm going to go up 3, and I'm going to go down 3. I'm going to draw my box. I'm going to grab my ruler and go through the corners. Through the corners, the corners, the corners, the corners, like so. Here they go. Okay, and through the corners over here, grab my corner there, like so. Okay, those are my asymptotes. Which way I'm going to go? I'm going to go side to side because x is first, but I need to put my foci in. So here's 2, 3, here's 4, so I'm going to go about right there. Here's 2, here's 3, here's 4, so I'm going to go about right there. And I draw it in like so. I should probably draw that in a different color for you. Easier for you to see. Yeah. Guess that was kind of not a good idea. There we go. That's a little better. Here we go. And it goes like this. Notice that it always goes to the box and around the foci. We'll talk about why that's true later on. Right now, I just want you to get the hang of writing your equations and getting things like that done. Okay? Next one. Oh, what the heck. Let's just try this one really quick and we'll keep moving here. All right, so once again, I have this 36 over here, so the only way to get rid of it is to divide by it. So I'm going to divide everything by 36. So now I have y squared over 6 minus, x squared over 9 equals 1, which tells me I have a vertical hyperbola. Ooh, this is going to be fun. I know that a squared is 6, so a is the square root of 6. More than 2, but not quite 3. We're going to call it about 2.4. And then I have b squared is 9. Well, the square root of that is 3. If I add them together, I get c squared is 15. And the square root of 15 is almost 4, so we're going to call that 3.8. And here we go. Whatever direction it's under, that's the direction I go. I'm going to go up and down 1, 2.4. 1, 2.4. I'm going to go left and right 3. 1, 2, 3. 1, 2, 3. Draw my box. Here goes. Like so. And I grab my ruler, go through the corners of my box. Looks something like this. Grab this one. Yep, something like this. And 3.8 is going to go the same direction as A, and A went up and down. Here's 3.8 is going to be right there. Here's 3.8 is going to be right there. So here's my hyperbola right here. Just like that. Just like that. Okay. So we've done several of those. That's a good thing. Let's see if we can write a couple of equations and then we'll be done. Here we go. First of all, let's take a look at some things to remember. When it comes to hyperbolas, first of all, A is always first. B is always second. All right. We also know that A squared plus B squared equals C squared. Okay. We know it's horizontal when X is first. We know it's vertical when Y is first. And our equations, again, look like this. X squared over A squared minus Y squared over B squared equals 1. And Y squared over A squared minus X squared over B squared equals 1. Okay, so if we can keep all of that straight, I think we can write some equations. Let me slide that forward up a little bit. Keep as much with me as I can. Let's take a look. I have two problems and then we'll stop. Okay, first one. I say the vertices are at plus or minus 3, the foci are at plus or minus 5, and I want you to write an equation. Okay, well, first of all, vertices are A and foci are C. That comes all the way back to the very beginning of the lesson. Same as before. Vertices are A, foci are C. They're in the X position, so that tells me this is horizontal. Okay, so if it's horizontal, I know I want X squared over A squared minus Y squared over B squared equals 1. That's not so bad. But I need C. There it is. I know that C squared is equal to A squared plus B squared. I know A is 3, so A squared is 9. I know C is 5, so C squared is 25. I need to know B squared. Well, if I do a little math, I get 16 for B squared. Notice I don't need B, I need B squared. So my equation is real simple at this point. It's X squared over 9 minus Y squared over 16 equals 1. Final answer. Let's try one more. Okay, in this case I tell you it's a horizontal hyperbola. I tell you the value of C, I tell you the value of A, and I ask you to write an equation. So I know it's horizontal, which means it's going to be X squared over A squared minus Y squared over B squared equals 1. I know that. I also know that A is 1, so it's going to be X squared over 1 minus Y squared over something equals 1. All I need to find is B squared. Well, I know that C squared is A squared minus plus B squared. Sorry, A squared plus B squared. Done too many ellipses lately. Okay, C is 2, so C squared is 4. A is 1, so A squared is 1. So B squared is 3. Again, I don't need B, I need B squared. So I write the equation, and here's my answer. Not so horrible. It's really, really, really important that we know which direction it's going so that we can get the equation in the right order. So I hope this works. We'll give her a shot and we'll see what tomorrow brings.